We're asked to use numerical evidence to estimate this limit. It's the limit as x approaches -3 of this quadratic divided by another quadratic. Numerical evidence, number evidence. Basically, this is saying use an input-output table. Now, to use an input-output table to understand a limit, we need to have x values that approach -3 from the left-hand side of -3 and see if that left-hand limit exists. And also, we need to find the right-hand limit as x approaches -3 from the right side. If the left-hand limit and the right-hand limit both equal a fixed output value, then we know that the limit exists and it will equal that value. So I'm going to go to Desmos and I'm going to define this function as the quadratic divided by the other quadratic. So I've defined the function here. There it is. We see that it has a vertical asymptote over here at +8. We're interested in the function's limit as x approaches -3. So if you just kind of glance at the graph, you see that it looks like at x is -3, the height of the function, the output of this function is approximately 0.8 maybe. It's a little below a y value of 1. All right, so it's definitely not a vertical asymptote there. So the limit's not infinity or -infinity or anything like that. If the limit exists, it looks like it's going to be something like 0.8-ish. So I'm going to now create an input-output table. I'm going to first explore the left-hand limit of f of x. So my input-output table plugs in x and outputs the defined function f of x. I'm going to explore the function from the left-hand side of -3. The left-hand side of -3 would be numbers like -3 minus 0.1. So that would be -3.1. And -3 minus 0.01. That's a little closer to -3. And -3 minus 0.001. And so forth. So I'm starting at -3 and I'm subtracting a little bit because we're looking at the left-hand limit as x approaches -3 from the left. Now you see, as you approach -3 from the left, as you get closer and closer and closer to -3 from the left-hand side, the y values seem to be approaching approximately 0.727. Approximately. So now we can conclude that the left-hand limit of this function as x approaches -3 from the left is approximately 0.727. The left-hand limit is approximately 0.727. Now, we want to find the limit as x approaches -3. So we've only found the left-hand limit. Now let's numerically explore the right-hand limit. So again, I can create an input-output table where we're inputting x and we're outputting that defined function f of x. This time, I'm going to approach -3 from the right side. So -3 plus 0.1. So that's a little bit to the right of 0.1. -3 plus 0.01. It's a little closer to -3 on the right side. -3 plus 0.001. And -3 plus 0.0001. So I'm sneaking up on x equals -3 from the right, and now I look at the outputs of this function, and we see the outputs, the y's, are approaching 0.727, just like we saw with the left-hand limit. So it appears that the right-hand limit is also 0.727. So that limit notation looks exactly the same, but since it's a right-hand limit, we use a little exponent of plus on that -3. Now that we have concluded that the left-hand limit and the right-hand limit are both about 0.727, we can now conclude that the limit as x approaches -3 of this quadratic divided by quadratic is about 0.727.